multiplying them, and it's normally it was written as like FG. Okay. What is the F circle, and then H was just like the G?
So the H,
It means the same thing.
It's just the same.
Yeah. Okay, so we're working on this problem. I think I messed up several times, and I said we'll continue tomorrow.
Yeah. Right, Sarah.
Sorry, Summer. Hannah's fault. All right.
Are you upstairs?
Hey.
Are you sharing the screen?
Probably not.
No, you aren't. Oh, no, you're not.
No, he's not even recording.
You stop sharing it like
It is recording.
we're sharing it now.
Probably because of me. Yeah. It's like, I was like, like vibrated.
Turn your camera off, Blake.
Ooh, where'd you get that from? Get what? Dollar General. That's what I'm doing.
Okay, so we're trying to find out the difference quotient. We've done f of x plus h for plugging x plus h in for x. Simplifying, I distributed the 2 properly finally. And does any of this simplify?
No.
So I can't do anything with that. Okay, so my numerator of the difference quotient says f of x plus h minus f of x. So this is f of x plus h. I'll go ahead and add that. Make sure I'm here. Okay. So this is f of x plus h. What I'm going to do is subtract f of x. Okay, so we're delayed. So by subtracting f of x, this would be a minus 2x squared. Y'all with me there?
Yes.
Plus 3x. And because f of x plus h is right above it, and those happen to be the same terms, I'm able to line them up. So what I have now is f of x plus h minus f of x equals, the 2x squares cancel. The minus 3x plus 3x cancels. I'm left with 4hx plus 2h squared minus 3h. Y'all good with that? Now back to what we're finding is the difference quotient. It's f of x plus h minus f of x divided by h. Okay, so I will take this, I will divide this by h. I will divide this by h. Can you see anything that's about to happen?
It's
You're about to
cancel
take away
them.
all the H's, aren't you?
Not all the h's.
No, not all, because one of them.
Oh, not the 4hx, but you take away everything else.
Okay. So what's going to happen is in the numerator, I can factor an h out of all 3 terms, which gives me h times 4x plus 2h, because there was an h squared, now there's just one h there, minus 3, and that is divided by h. Those h's cancel. So the answer to this problem is of what is the difference quotient. The difference quotient is 4x plus 2h minus 3.
That was a lot.
So many times when working with the difference quotient, your answer is going to be fairly simple. Okay? If you're doing this and you don't find that you're canceling a lot of stuff, then you probably messed up somewhere. Okay?
I think I just said one in this class.
You're okay. So there's the whole problem. Screenshot it if you need to. All right, next slide. All right, this slide needs some work here. 1 second.
FOG?
Wait,
See, that's what I was talking about.
Okay. The diagram below shows a function g that assigns to each x in its domain a value g of x. Then another function f assigns to each g of x in its domain a value f of g of x. This is a two-step process. Takes an element x and produces a corresponding element f of g of x. So here's what's happening. You have some value x. The x goes into this. You know from order of operations, if you saw this, you would have to do the inside first, right? Order of operations says you do inside the parentheses first. So if I give you an x value to plug into f of g of x, you're going to take that x value and plug it into the g function. Do the math. You're going to get some kind of an output. Whatever that output is then plugged into the f function. Do the math. You'll get an answer. Sometimes composition functions f and g are written as f circle g. This is a composition. This means f of g. This means the same thing as this. As we're about to work problems, you're going to see that every time I see this, I rewrite it to make it look like what I'm used to. Okay? And if I flipped it around, if it said g circle f, that means you're going to take the f function and plug it into the g function. There's the answer to your question.
like it would be g of f of x?
You plug it into the inside first.
Yes, but whenever the f circle g, that one.
That means the same thing as this.
Oh, okay. You're saying
You're about to see, we're about to do one, and you'll see what I do.
Gotcha.
All right, next slide. And this is what I just told you. F of g of x is the same thing as f of g of x. Okay. Write down those two functions. We have f of x, which is 2x minus 1. And we have g of x, which is 4 over x minus 1. Part A says find f of g of 2. That means f of g of 2. Working inside out, I need to figure out what g of 2 is. That means we'll take the g function, and anywhere there's an x, we'll replace it with a 2. So g of 2 is equal to 4 over 2 minus 1. Well, 2 minus 1 is just 1. 4 divided by 1 is 4. So g of 2 is 4. This 4 value is now going to be plugged into the f function. G of 2 is 4. So 4 can replace g of 2. F of 4. I'm now dealing with the f function. 2 times x, which is 4, minus 1.
Okay, so just one more step on the f of x function. Okay,
Not the.
Okay. 2 times 4 is 8,
negative 8.
Ooh.
minus 1,
Oh,
7.
You know what?
Negative.
I saw that as multiplication.
So,
I completely
Yeah.
agree with that.
of g of 2 is 7.
Oh, sorry.
Okay, that's what I looked up.
Go
Never mind, I was gonna ask if it was always gonna be the 4 on top, but it's G, right?
The 4 on top
Yeah.
is the G function.
Yeah.
Yeah. Yes, ma'am.
I'm so confused.
So, this is kind of going ahead, but like,
That's okay.
if it's, are you always gonna do like G first, or is it the second one? So you, the
That's
second
why-
question, you would do F first?
Dummy. That's why,
Like, her-
when it's written this way, I rewrite it. What happened?
Oh, I thought you called
So
her
if
a
you-
dummy.
Yeah,
No, it was the button.
I know, but you kind of made it. You were talking to her, so you said it kind of sounded like you called her.
I did not call you a dummy, I'm sorry. This is funny.
So if you rewrite the second equation, it would be G of F of 2.
Well, of -3.
I mean, of -3.
Oh, wait a minute, I did it backwards.
Yeah.
Okay. You.
I mean, and you could have these things nested. You could have G of F of G of G of F of X.
Aw, crap.
So like the circle is just a
Wrong.
parenthesis, or like,
I read it as of,
Oh, I thought it was.
and I'm so
I put
used to
the
reading
three-
this as F of X,
It's just FX.
so I read that as of. So this is F of G of 2.
Or fog. Wait, what that means. Oh, you're making my head.
or you
Wait,
put the
wait,
negative
wait.
3 inside the parentheses, and then, or like after the F, and then you change the circle to a parenthesis.
Okay. So this is G of F of -3.
I'm so confused on how. What are.
Just don't be confused. I'm just kidding.
Ask the
what part
question.
are you- Like, I just don't get. Like, what did you just do on the last?
Solved it.
I know.
So at
I
first-
don't get how you.
At first, you solve g of x, which is the 4 over x minus 2, or minus 1.
So we're just plugging in the two like the last one.
Oh no.
Remember how he said he rewrote it because it was more comfortable?
Yeah.
Well,
that
that's why he
doesn't look
rewrites it
comfortable.
because it.
Okay,
Ew.
very simple math.
It's
No,
not.
Okay.
3 minus
If I told you to simplify this, what would you do first?
Do what's in the parentheses or like right?
So tell me exactly, what would you do first?
2 plus 4.
Okay, because it is on the inside of the outer parentheses, or in this case brackets.
Yeah.
So we're gonna work inside. We're gonna simplify that, and that would give us,
6.
right? Now what would you do next,
6 minus 5.
right? Because we started inside, and we're moving our way out,
Yeah.
right?
1.
Okay.
Yeah.
Okay, I'm
That's-
doing the exact same thing. I'm gonna start on the inside,
Okay.
okay? So before I can worry about, before I even care about the G function, I wanna know what F of -3 is.
Okay.
So F of -3. I take the F function, which is 2x minus 1, but I'm gonna change the x to a -3. I will simplify that. 2 times -3 is -6. -6 minus 1
8. Just kidding.
is -7. So f of 3, this thing right here, f of 3 is -7. F of -3 is the same thing as -7.
Okay.
So because I know that f of -3 and -7 are the same thing, I can find g, let me move that over. I can find g of -7.
Okay.
Now I'm dealing with the g function. Here's the g function. 4 over x is -7 minus 1.
-8. -4 over
4 over
-8.
-8,
-1.
-1/2. So f of -7 is -1/2. Where'd the -7 come from? Well, that was f of -3. So I now know that g of f of -3, which is what the question asked for, is -1/2. Or I could have written it as this g circle f, and I still get the same answer.
Okay,
Is that clear now?
thank you.
Questions? Any other questions? Thank you.
I wrote it different.
Yes, ma'am.
This is not important, but is there a name for the circle?
I don't remember.
So wait,
Probably.
could
You want to call him Fred? We'll call him Fred.
Who's Fred?
Oh,
Okay, so could
So we'll just call
G O
it
F.
F Fred G. I really don't remember.
so instead of writing G, of F, that whatever that however you word it, can you do the
You want to write it that way?
yeah write it like can you do
Yeah,
it
like I
like
did here.
yeah? Oh,
So I did them both two different ways. Just they mean the same.
Would it? Can you split that into like the circle?
I don't know.
So in my labs, I wrote it like the second one.
No, my lab.
Well, my lab is probably gonna write -1/2.
Yeah, you write negative one half. You don't do that.
I have not gone on to TPA.
Okay.
I wouldn't say that.
Well, it was more confusing because
Hey, buddy.
it was F of when I did it. It was F of H, not F of G. So when I looked it up, I found no answers.
Oh,
Then I eventually got to F of F.
that's your note.
Okay. F of x is the square root of x. G of x is 4x plus 2. I want to find f of g of x, and then we're going to talk about the domain of that guy. Okay. So remember, this is the same thing as f of g of x. Do I have a value for x?
No.
No. What this means is I'm going to take the entire function g of x and plug that entire function into the f function. So the f function is pretty simple. It's the square root of x. But what's x?
4x plus 2.
X is 4x plus 2. Hannah, you might want to pay attention and be writing stuff down. That way you're not so far behind when you're ready to move to the next slide. Can I
I wasn't
simplify this?
behind. I just wanted to
Yes.
make sure I wrote the answer right.
Okay, Tyler thinks he can simplify this.
You choose prime, so I don't think you can.
I
cannot square root it.
I can't simplify that.
Maybe I can.
Okay,
30.
so folks, this is the answer for what is f of g of x. Okay? Now that's part of my answer. The next thing is, what is the domain of this? Now remember, when you're doing problems, you start off by assuming that the domain is all real numbers. Then you start saying, oh, but we got a problem here. Okay, we're taking a square root. Where do problems happen in the real world when taking square roots? You cannot take the square root of a negative number in the real world. We could go complex, but we're not going there. So for the domain, for this problem, whatever is inside the radical, 4x plus 2 must be greater than or equal to 0. Okay? Let's get x by itself. What do we do?
Divide by x.
No, mine's 2.
Subtract 2 from both sides.
You can do it that way.
4x is greater than or equal to -2. Next step, divide by 4. X is greater than or equal to -1/2. Let's write that in interval notation. Where does the value of x start?
Oh, -1/2.
Oh, wait, you said.
Can it equal -1/2?
Yes.
Okay, so it starts at -1/2 and goes to what?
Infinity.
Infinity. And how do you close infinity? Always.
Is that the name?
There's your domain.
Is that supposed to be a face?
It says or.
Oh.
So it kind of looks like
I thought it was looking at me.
Okay. Read mine.
Damn.
You can't even get a wink from the whiteboard. So this is f of g of x, and this is your domain. It can be written in different ways depending on what they're looking for. Couple questions real quick. Look at the f of x. Just looking at f of x, what is the domain for f of x? What's the domain here?
Oh, wait, it's like, it starts at zero.
Starts at
right?
0 and goes on to
And then
infinity.
it's like
Okay,
this.
because x cannot be
Negative.
negative. So the domain for this function is 0 to infinity. What is the domain for g of x?
I think it's all related.
All real numbers. There's no problems here. Okay? It's kind of interesting that right here, we said the domain x has to be greater than or equal to 0, but all of a sudden down here, this x can be negative still, and that's okay. Because this negative 1/2 is not being plugged into this function. This negative 1/2 is plugged into the g function. By plugging negative 1/2 into the g function, we get 0, which would be the smallest possible number. Questions on this? Domain tends to trip people up.
Wait, so how'd you know that it started at -1/2? I know that you.
Because I made the statement of 4x plus 2, which is inside a radical, cannot be negative. 4x plus 2 has to be greater than or equal to 0. And then I solved for x.
Okay.
Okay? The two biggies on domain, you can't take the square root of a negative number, and you can't divide by 0. So if you have a variable in the denominator, there's probably a problem somewhere. If you have a variable inside a radical, there's a problem somewhere. Okay?
Wait, so where's the bottom?
There is no bottom on this one. But since you asked, let's go to the next problem. Actually, in a minute. G of f of x. So we have the exact same f of x and g of x that we had just a moment ago. They haven't changed, but we've switched. Instead of f of g, like here, we now have g of f. Which means take the g function and plug in the f function.
So we're not doing that today.
So here's the g function. 4, there's an x, but I'm replacing x with f of x. So instead of x, I'm going to write
Square root x.
square root of x plus 2. This is g of f of x. Do we have any restrictions on our domain?
Yes. Wait, no. Wait. Yes.
Where's the problem?
Can't be in
Whatever is inside the radical must be greater than or equal to 0. Simplify that. Okay, we're done. Write it in interval notation. We will start at 0 and go to infinity. And that's all there is to that problem. Questions there?
Wait. Oh, okay.
I'm going back.
No, never mind.
Which question?
Oh, I was still writing it. That's an 8, not an infinity. Okay, I'm done.
Moving on. F and G are now changed. F of x is now 6 over x minus 3. G of x is now 1 over x. I want to find f of g of x and its domain. I want f of g of x which means take the f function, and anywhere there's an x, I'm going to replace the x's with the g function. So I have 6 over x. That x needs to be replaced with the g function. So instead of x, it's going to be 1 over x minus 3. Don't ever give me an answer that has a fraction inside of a fraction. We have to simplify this. I'm going to multiply this fraction by a fancy 1. What is the denominator I want to get rid of?
The fraction, so 1 over x.
I want to get rid of the x. I got to get rid of the x. Always, when you have a chance, get rid of your x. Get them out of your life.
Too many x of that.
So, is x over x 1?
Yes.
Okay, so that is the 1 that I'm going to multiply by. Across the top, I have 6 times x. Across the bottom, I have this x has to be distributed to both of these terms. So it is x times 1 over x, 1, and x times minus 3,
Negative 3x.
minus 3x. Okay, no problem. This is f of g of x. Composite functions are Annika's favorite things.
Oh, yeah.
Okay, where's my domain problem?
It'll be really short.
Do what? Bottom can't be 0.
Oh.
Okay, so let's talk about the domain. 1 minus 3x cannot equal 0. Simplify that, we'll subtract 1 from both sides. Negative 3x cannot be negative 1. Divide both sides by negative 3. X cannot be 1/3. But there's another problem.
Wait, is it not in, oh, never mind, they're both negative.
There's one more problem. And the problem comes from the g of x. Notice that we're plugging stuff into g of x. Okay? That's where we started. Do you see a problem with g of x?
It has.
Negative.
Do you see a problem here?
Yes.
What can't be 0? X can't be 0 because if x was 0, then g of x would be undefined, 1 over 0. So g of x, x cannot be 0. X can be any other number. It can't be 0, and it can't be 1/3. Those are the only 2 numbers that it can't be. So we need to write this in interval notation. Starts at negative infinity. And we're good until we get to 0. Parenthesis. Union. It starts back up again at 0. And we're good until we get to 1/3. Union. Starts up again as soon as we pass 1/3 and goes to infinity. This is the domain. Okay. So x can be 3. Can x be 3?
No,
This x can't be 3.
f of x can't be 3.
Okay, this x can't be 3. But doesn't 3 fall in right here?
Yes.
So 3 works for this composition, but it doesn't work for this. What happens if you plug in 1/3 right here? What is 1 divided by 1/3?
3.
That's why it doesn't work over here.
That I really struggled to figure out that.
Okay, does that make sense? If x was 1/3, the first thing you'd do is you would take that 1/3 and plug it into the g function, which is totally allowable. I can plug a 1/3 in right here. But 1 divided by 1/3 is 3. That 3 would have to be plugged into the f function, which is not a part of the domain. How y'all doing? Okay, no questions? We're about to flip it around. Same functions for f and g, but now we want g of f of x. Which means I'm going to take the g function, 1 over x, and replace that x with the f function. So I get 1 over, the f function is 6 over x minus 3. I've got a fraction and a fraction again. Got a problem. I'm going to multiply this by to get rid of that denominator that's in my denominator. X minus 3. Do what? You don't need the 6. It's just the x minus 3. Just the denominator. In the top, I've got 1 times x minus 3. Well, that's just x minus 3. And in the bottom, I have 6 over x minus 3 times x minus 3. So those x minus 3's cancel. I'm just left with the 6. Do you see any problems with the domain?
Could you simplify?
You can simplify this?
Can't you simplify the -3 and the 6?
How?
Oh no, never mind.
You're trying to make that a 1/2 kind of going on? Remember, you can only do that if you're just multiplying. As soon as you start adding and subtracting, it jacks all that up. Okay, what is the domain of x minus 3 over 6? Do you see any problems with that? There are no problems with that. Does that mean the domain is all real?
No.
Well, we've got to look at what we started with. What function are we plugging in?
F.
We're plugging the f function in. Does the f function have any limitations?
Cannot be 3.
Yes. So because we're using the f function first, we must state that that is part of the domain of the composition. So the domain of this thing is x cannot be 3. So that would mean the domain is -infinity to 3 union 3 to infinity. And we're done with this problem. Questions, comments?
You can't simplify that?
Do what?
You can't simplify that?
That,
Yeah.
not that I know of.
Oopsies. Somebody teach me how to simplify.
I've tried.
Wait.
I guess if a person wanted to, they could write that as 1/6 x minus 1/2. I guess you could do that.
So I thought it was gonna be.
One what? Wait, what?
Do I? Okay, moving on. We're going to show that g of f of x is not equal to f of g of x. I've got two functions, f of x is 4x plus 1, and g of x is 2x squared plus 5x. Bless you.
That looks adorable.
So I'll start with g of f of x, which means take the g function and replace the x's with f of x. 2 times x, well that's 4x plus 1, squared plus 5 times 4x plus 1. Next thing I do is distribute the 2, right? Yes, no?
Yes.
Maybe.
No, we do not distribute the 2.
Foil.
Okay, foil it. So, what is 4x plus 1 squared? And the first person to tell me 16x squared plus 1 is going to get kicked in the knee.
16x squared plus 4x plus 4x plus 1.
Correct. And since you said 4x twice, I'm going to say
X.
Wait.
16x squared plus
8x.
4x and 4x is 8x
Oh,
plus 1 plus
20x plus 5.
20x plus 5. Now I can distribute the 2.
32x squared. 16x plus 2.
I can now combine like terms.
32x squared
32x squared
plus 36x
plus 36x
plus 7.
plus 7. That is g of f of x. What is f of g of x? Take the f function, anywhere there's an x, replace it with g of x. Distribute the 4. Can I do anything else with that?
Oh, no.
Are those the same?
No. No.
Clearly different. 32x squared plus 36x plus 7 is definitely different from 8x squared plus 20x plus 1. Is it possible that g of f of x and f of g of x were equal?
What do you mean by that?
The answer is yes, it is possible. If g of f of x is equal to f of g of x, then the functions are called inverse functions. But we're not going to talk about that until section 4.1.
That's bait.
I want y'all to be excited about what's coming up.
Right, that's what I'm saying.
Wait, was that the answer? No? Was the answer no?
That is the
Well,
answer.
they gave us the answer, saying that.
They're inverse?
That they would be inverses, yeah.
wait, I thought they weren't equal.
Ours weren't. Ours weren't. My question is it possible that they are?
Wait.
The answer is yes,
So
it is
they aren't
possible.
inverse.
These aren't.
So the
Yeah,
answer
that's
These
what
are
she
not
was
equal, but
asking.
it's
That's not
asking
the
if,
question of this.
in general,
Yeah.
can g of f equal f of g x? It's not talking about those specific numbers, it's just saying.
No, I was asking for the answer to the question.
And we will get to
I
this.
understand what you're saying, Leilani.
I'll just put it in.
We'll wrap this up on Monday.
Okay, I like the question then.